Okay, so on this one, we're starting with a number of molecules, 1 billion molecules. That's one number, 1 unit, so I'll start with that there. I'm going to need more room. Okay, and I don't want molecules. Scrunch this up. Notice that you don't want to abbreviate molecules with just mole, because then, M-O-L-E, because then it looks like mole instead of molecules, and you don't want to mix those up. They're different things, and it'll throw your math way off. Anyway, so I don't want molecules. What should I go to next? In chemistry, when in doubt, if you have a doubt, you want to go to moles. That is often the first step. If you can convert to moles, then you can convert to other things from there. So how do I go from moles or molecules to moles? I'm going to use Avogadro's number. The 6.02 goes with the molecules. It's the definition of 1 mole. So I'll take that off. Next step, I don't want moles. I want grams. Mass is grams. So for this step, how do I know how many grams and moles? What's the relationship? It's molar mass. So I need the molar mass of water, which is pretty easy. There's 2 hydrogens and they're 1 each, 1.0, plus there's 1 oxygen, 16. That gives me 18 grams per mole. Again, when I use the molar mass, the number stays with the grams, so 18 grams per 1 mole. And then I get my answer. By the way, if you're not getting my answers, then it's probably a calculator issue, maybe with entering these in scientific notation. See me if you can't get it to work out to get my numbers. Okay, so is this a reasonable number? Well, we're talking about the mass of 1 billion molecules, and 1 billion is a really big number, but remember, molecules are tiny, 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 and even 1 billion of them should have a really small mass, and this is a very, very small mass. So yes, actually this number makes a lot of sense.